Hello everyone. I just quickly wanted to take on a small challenge and try to explain as best I can. I've seen it all over the internet. It's been confusing me. And simply put, it's this problem here. Assuming portals can move and ignoring all the trolls and everybody else that say portals can't move, yes, they can't move. Whatever. If a portal could move and it collapsed itself, it pushed itself onto a cube, would the cube fall out of the next portal, or would it shoot out of the portal, saying it took on the velocity of the moving portal? Does it take on the moving velocity, or is the system individual to the cube itself, and therefore, because the cube has no momentum, the cube has no momentum here? Or does the cube gain momentum and velocity through the system of the moving portal? I want to try to tackle that question. It's been confusing the crap out of me, and my basic understanding of physics hopefully will help us along the way. And so first, we need to understand portals as they are. And the first thing we can say is we have a portal. Portal 1, orange, and Portal 2, blue. And as GLaDOS puts it best, speedy thing goes in, speedy thing comes out. Therefore, if we have an object, and the object moves into the portal at a velocity of 1, velocity 1, it will come out of that same portal at an equal velocity in the other direction. V1 equals V2. And other great things about the portals, they don't change mass. Therefore, the mass of Object 1 is the mass of Object 2, because mass Object 1 and Object 2 are the same object. So this could essentially be resolved to say Object 1 is Object 1. And it keeps going. There's more to these. We have a height. Height here, and a height here. We'll represent this one as x1, and we'll represent this one as x2. And if velocity is maintained, in and out, acceleration of gravity is the same on both sides, x is going to maintain itself also. Therefore, x1 equals x2. Portals are our perfect system. They maintain everything in a situation where we can neglect, where we can neglect and ignore wind resistance and other figures of that sort. And it even maintains even further than that by kind of going against science here, since, well, it is a portal. But for example, if we take an object and we put it up here with this portal, and the other portal sits way down here, right? And we move an object, that was weird, and we have an object, and it goes into the portal at V1, and we have another object, and it comes out of the other side at V2, and they both went in at a height of x1, and this one came out at a height of x2. Regardless of how high this is here, being y, it's going to ignore that. The portal essentially acts in the same situation here, ignoring the fact that a portal is in a different location. Therefore, we have speedy thing go in, speedy thing come out. V1 will equal V2. x1 will equal x2, and the mass of one will equal the mass of the other. Nothing will change. The biggest difference being the total height achieved. If this is 100 and this is 50, will be different. The total height achieved, but the height achieved from portal will be the same because it acts as simply a portal to another area, maintaining all of those characteristics. So, with that being said, we move into our next question. The next question being, what happens in this situation? Well, it's kind of hard to explain. It's different. It's interesting. Where do we go? What is correct? What is incorrect? And something I think people are ignoring is rate of change. You know, a rate, and it changes. If we have portal blue here, and we have portal orange here, right? And we have an object at this location. Here's our object. Object is here. Our object has no velocity. Velocity equals 0, not moving. And this portal has a velocity of 1. It is moving in this direction. The portal is moving toward our object. This portal, on the other hand, is staying perfectly still at 0. Velocity is 0, velocity is 1, velocity is 0. What happens to the cube? And so let's slow this down. Let's make the rate of change so small that we can look at each individual part of the cube. So when the portal reaches the cube at this point, at that velocity of 1, that means that much of the object is going to be sticking out of the portal on this side. Correct? A little bit goes in, a little bit's out. However, this portal is moving. This portal is not. But this object has to come out of the portal in order to move through it. So, if it is moving over the portal at 1 inch per second, 1 1,000, 2 1,000, 3 1,000, that's 3 seconds. That's 3 inches that we have covered this cube. That means that this portal is going to cover it at the exact same rate. It has to come out of the portal at the same rate. So, guess who has a rate of change? The box. The box is now coming out at 1 inch per second. The box has to come out of this at 1 inch per second, assuming we have a frictionless surface. All right, we'll call it ice or whatever, Okay, frictionless surface. This object's going to have some kind of velocity relative to this portal. If we stood here and we looked into the portal, this box is coming at us at a rate of 1 inch per second, regardless of what's going on here. If we knew nothing about portals and something was coming through a door at 1 inch per second, it's going to keep going at 1 inch per second unless something acts upon it. In this situation, yeah, the box isn't doing anything. A portal is acting on the box and eliminating it, essentially. And then it's going off into nowhere. We don't know where it's going unless we, too, were inside the portal. So with that being said, yeah, there is a little bit of a gain for this box to create a velocity. Now, let's assign a mass to both of these. We'll assign a mass of 10. Mass 1 equals 10 on both sides. So the mass here, 10. The mass here, 10. Therefore, now let's find a momentum between these two. If this has a rate of 1 inch per second and this has a mass of 10, right, we can solve our momentum equation. Momentum equals mass times velocity. Momentum equals mass of 10 times our rate of 1 inch per second. Momentum equals 10. Therefore, this box now has a momentum because the relative portal has acted upon it over so much. If it didn't, then there would be no way for the box to come out. Simply put, sure, we could say a door fell on it, but a door's not a portal. It's moving from one location to another location regardless of what's on the other side. Because this is the universe. The universe opened a portal, and the universe is acting upon the box. And this is why it doesn't make sense in the real world, and why some people, I think, are getting confused. Over here, this is the universe, and the box is acting inside the universe based on the properties of it in a different universe. In the different universe, it wasn't moving. But relative to this universe, it is moving. And therefore, when it comes out of the portal, it is moving. Now, we're not saying that these are different universes because it's open in the same universe, but, I mean, can you essentially imagine passing the universe through the universe itself? That's essentially what's going on when we're inside the same universe. So, now it comes down to answering that question. This question here. And we're going to do it with, well, some science. So we're going to add values to this. So VO equals 0. The initial velocity of this portal is 0. And the final velocity at where the block is equals question mark. We don't know what it is. And it's accelerating at the speed of, let's say, gravity. Gravity's easy. It's falling down at gravity. We're ignoring this piston thing. It's not pushing it. It's accelerating just by fall of gravity. So gravity equals 9.8 meters per second squared. So we're falling. Well, we need to figure out this distance here in order to figure out how fast it's going. So x here. So using some basic physics equations, Vf squared equals Vo squared plus 2ax. Vf equals, we have an initial velocity of 0 for the plate, so we can cross this out, equals the square root of 2 times acceleration times x. Acceleration being gravity. Velocity equals 2 times 9.8 times, we'll give this an x value of, let's call it an even 10. 10. Sorry, we're trying to find velocity, not this distance. Sorry, found that. Velocity equals the square root of 196. Final velocity equals 14 meters per second. So at this point, when this plate reaches this point here, it will have a final velocity equal to 14 meters per second. And going back to our other diagrams, speedy thing goes in, speedy thing comes out. And the rate of change of a portal moving upon another portal, this object is going to gain a final velocity of 14 meters per second. Therefore, the final velocity of this box does exist, and it is 14 meters per second, and therefore, it does in fact fly out of the portal. Well, thanks for watching. Hope it makes sense to you. If it doesn't, please leave a comment below or whatever. I don't know. This is my first YouTube video. I just been kind of bothered by everything and wanted to give this a shot. Hopefully this explains it to some people. We have to consider that space is relative. Everything is relative to each other. Thanks for watching. Hopefully it makes sense to you guys.